Today we're learning about the surface area of prism, so we're going to work out a few homework problems today. We're going to look at number 3 because it has some fractions, and I know sometimes you get a little tripped up on the fractions. So we'll use number 3 as our first example. I'm going to slide this over so I can do my work on a piece of binder paper because you're going to need quite a bit of room to really organize this. Now before we start, let's go ahead and identify one of our sides with how we're going to label it. So looking at our figure, this kind of rectangle at the top is the top of the figure. I'm going to highlight that for us so that you can really see what the top looks like. The top is there. The bottom that is similar to it is going to be right here at towards the bottom of the page and where it's labeled 8 1/4. Okay, then this is going to be our left-hand side, our right-hand side, our front is facing us, and then our back is kind of hidden with those dotted lines behind. Okay, before we begin, let's go ahead and change our fractions to an improper fraction first. So we have 6 2/3. And we want that to be an improper fraction. So if we change 6 2/3, we end up with 18, 19, 20 over 3. And if we change 8 1/4 to an improper fraction, we end up with 33 over 4. So now anytime we use those numbers, 8 1/4, we're going to substitute 33 1/4 in for that. And whenever we need to use 6 2/3, we're going to end up using 20 1/3. Okay, so let's go ahead and start finding our individual areas and then adding them together. So for the top, which we shaded pink, our area is going to be this 20 over 3 times the 33 over 4, because this length here is the same as this one and it's the same as this one. So this length here is also going to be 33 over 4. So the area would be 20 over 3 times 33 over 4 for the top. Now I'm going to wait to actually solve it until we get to the end. Let's go ahead and just label everything. The bottom is going to be identical to that top. So it's also 20 over 3 times 33 over 4. For the left-hand side, which is this side right here, we have a length of 12 units, 12 yards, and then the width is the 6 2/3 or 20 over 3. So for the left-hand side, we have 20 over 3 times 12, and the right-hand side is going to be the exact same area, 20 over 3 times 12, because it's this rectangle right here. Here's my 12, here's my 20 over 3. For the front, we have the 8 1/4 by 12, or the 33 over 4 times 12. And the back is going to be the exact same shape as the front. It's right here. So we're going to have our 12 by our 33 1/4. Next, we can go ahead and start to find the individual areas for all of those. So you can either multiply straight across and then simplify your fraction, or you can simplify as you go. Now, I prefer to simplify as I go because it makes the multiplication a lot easier later. So I have a 3 on the bottom and a 33 on the top. Those can be reduced. 3 goes into 3 one time. 3 goes into 33 11 times. The 4 can be reduced with the 20. 4 goes into 4 one time, 4 goes into 20 5 times. So now to find my answer for my area, 5 times 11 is 55. over 1, which we do not need to write. So my area for the top is 55 yards. Now for the bottom, notice it was the exact same problem. So I don't need to redo that one. I know that the bottom is also going to be 55. Now for the left-hand side, we're taking 3 and we're dividing it by 12. 3 goes into 3 once, 3 goes into 12 4 times. So 20 times 4 is equal to 80. The right side of the triangle is exactly the same as my left. So 3 goes into 3 1 time, 3 goes into 12 4 times. So again, 20 times 4 is 80. For the front and the back, they're identical. 4 goes into 4 1 time, 4 goes into 12 3 times. So when I multiply across, 33 times 3 is 99, and the back is going to be the exact same. So now I have all of my areas, and now I can just add straight down to find the actual surface area of the entire thing. So 5 plus 5 is 10, plus 9, and 9 gives me, we have 28. And then we're going to go ahead and add that column there, and we end up getting 46. So our total is 468 yards squared for our answer. Now we're going to look at number 6. Now number 6 is a triangular prism. So we need to make sure that we're using our correct formulas to find area. Area of a triangle is 1/2 base times height. So again, let's identify, here is my triangle in the front. So that's going to be the front of our figure. So when we write front, we're finding the area of that colored triangle. So we have 1/2 times, now here's my 90-degree angle here. So my height of my triangle, the two side lengths I'm using is 4 and 5.2. So times 4 times 5.2. That will give me the area of that triangle. Now the back is going to be identical to that. So it's this other triangle. So we have 1/2 times 4 times 5.2 as well. Now the base or the bottom of this figure is going to be 6.6 times 9. So the bottom is 6.6 times 9. The left-hand side is kind of awkward, but it's this side of this whole triangle over here. So the left is going to be 4 times 9. And the right is going to be 5.2 times 9. Now we can go back and find the areas of all 5 sides. So notice in a triangular prism, you're only going to have the 1, 2, 3, 4, 5 sides. All right, so when we go ahead and multiply this across, the triangle is going to end up being 1/2 times 4 times 5.2. You can put 0.5 in your calculator for the 1/2. So 0.5 times 4 times 5.2 should give you 10.4. The back triangle is exactly the same, so it's also 10.4. The bottom, 6.6 times 9, gives you 59.4. 4 times 9 is 36. Notice how I'm going to line up my decimal points. It'll make it easier for you to add later. So really there's a 0 here. And then 5.2 times 9 gives me 46.8. Now I can add all of my sides up to give me my answer. So 4 plus 4 plus 4 plus 8 is 20. So I'm going to carry my 2. My decimal place goes right there. It just goes straight down. And then 2 plus 9 plus 6 plus 6 is going to give me 23. And then 2 plus 1 plus 1 plus 5 plus 3 plus 4 is 16. So my answer is 163 millimeters, because that was the units we were using, squared. Now we're going to look at number 9. Number 9 is a word problem, but it has volume in it, which we're learning volume tomorrow, so we haven't learned that part. So I'm going to do the first part of it for you, and then we'll do the surface area together. So it says a company needs to package hazardous chemicals in a special plastic rectangular prism container that holds 80 cubic feet. So it's giving us how much the container holds, not what the surface area is. But we want to find a whole number of dimensions of the container that would use the least amount of plastic. So at the end, we want to find what the surface area is going to be. So if our volume is equal to 80, we're looking for a shipping container, so some kind of box that we can put our hazardous materials in. Now, we need to know 3 different dimensions for that box. So I took the easiest one I could find was 8 by 10. And then we could split this even further. So we could split this into 2 times 5. Okay, so we end up having 8 times 2 times 5 gives us 80. So that's one way to do it. Now, if that was the dimensions of my box, let's say that this was 2, this was 5, and then this length over here was 8. Okay, so if I multiply that up, it will be 80 for my volume. So now I have some dimensions that I can find the surface area. So my surface area, I have to add all of the sides again. So let's add in some of our dotted lines so we can really see what's going on here. So for the front, we would have 5 times 2. The back is going to be identical to that. Our top would be 5 times 8, which is the same as our bottom. And then our left and right sides are going to be 2 times 8. So we know our front would be 10 and our back would be 10. Our top would be 40 and our bottom would be 40. Our left would be 16 and our bottom would be 16. So then if we add these up, we know 10 plus 10 is 20, 40 plus 40 is 80, 16 plus 16 gives us 32. So if we add those up, we end up with 132 square feet, or feet squared, and that would be our surface area. Now to find something with the least amount of plastic, we would have to play with our dimensions here and change it a little bit. But for now, we can use this as our example. If you want to, for a challenge, go ahead and try to find different dimensions that you would multiply together to get 80, and then find the surface area and see if you can get a surface area that is smaller than 132.